Hello, good morning, evening, afternoon, whatever time zone you're in. Hope everyone's having a pleasant weekend. Before I start talking anything really, quick sanity check. Is the resolution okay today? Last week it was not. We had weird vertical output as the primary video, which was 100% not my intention. So good res, that's fine. I'm also again trying to dual stream to Twitch, and apparently that is working, but I'm not listening to it and not looking at it, so see what happens. YouTube Studio also popped up and said that my audio bitrate is 0, but I assume you guys can hear me, so that's probably more than 0. Link Twitch in chat. Hold on one moment, caller. My channel, where is it? If you're interested, I assume some people have a preferred platform. It makes no odds to me. I'm not, but it would be fun to maybe try and see if we can build a bit of a following on Twitch. But whatever works for you guys really doesn't worry me. Keen to know what the quality is like on Twitch, because I had to massively drop the bitrate to accommodate for Twitch, which hopefully means it hasn't impacted YouTube experience. Like, I'm not doing fast-paced gaming or anything, it's just me chatting and typing code on a keyboard, so it doesn't have to be presumably super high quality as long as you can read the text. Yeah, so I really enjoyed doing the code review last time, but super fast-paced typing, just the fastest. I really enjoyed doing the code review last time, and thank you. I've had some more suggestions in, which is good. I've just not really had a chance to kind of go through them all, and it's kind of a cross between, like, I try and do as much of it like raw and live as possible, but sometimes I do look at all the ideas before to pick one, and there are some really interesting ones in there. There's some ones I would actually like to go through, but they are in areas that I'm not well versed in, so I want to do a bit of homework before them, so I'm not ignoring them. I just want to kind of make it a good experience for everyone. So I kind of want to just get back to doing some coding today. That's what we're going to do today, and then we'll see where we go from there. What I've had an idea for a while, and I think I mentioned this last time, is I want to start implementing bits of the C++ standard library from scratch, because I think there's a huge amount of learning opportunity potential there for myself as well, because it's always good to kind of go through the mechanics of how a lot of these things work. I'm in no way suggesting that you should implement them yourselves and use them in anger, but I think the motions of going through and we're figuring out like how actually does like an optional work, or how actually does a tuple work. I think there's a lot of knowledge. There's a lot of interesting stuff you can kind of get out of that. So I'm going to start with that today, and I kind of plan on this. Stub move is just an unqualified cast to an R-value reference. Boom, done. Next. But anyway, stuff like that, a lot of the utility functions we could probably go through. So I'm just going to start today, and we're just going to write some code, write some tests maybe, and see how it goes. And I think this is kind of one of those, a series that could just keep going on and on and on. So without kind of committing to any time frame, or we're going to do this every week, it might be something we just dip in and out of as when we want to. So that's my plan. I'm going to start writing some code. Please reach out and ask questions as we go along to make anything, if anything isn't clear. I'm at 100% not an expert in any of this, and I'll probably make mistakes, and I will definitely make some typos. But we can kind of go through this together. As always, I will try and respond to all the questions. I will definitely respond to super chats and stuff like that. But yeah, let's go going. So, breather before we dive in. I want to start with what is something that probably everyone has used. It's probably I would say one of the most useful vocabulary types of C++, and that is the humble unique pointer. I think there is a lot of interest. Hopefully it doesn't sound boring, but because there's a lot of interesting stuff that kind of goes into unique pointer to make it work, and some of the requirements that you're guaranteed to get. So I think what we'll be doing is I'll probably mainly going off CPP-ref, but there's also the standard itself. I find the wording in the standard considerably harder to parse, and much more language lawyery, whereas CPP-ref tends to be a bit more for actual, us mere mortals to try and figure out what's going on. Um, so someone said, yeah, std move is just a cast. It's just a cast an R value reference. I think if you even look up the, but of course, like, I don't want to sound belittling, like, oh, it's just a cast an R value reference, because one under the hood, does it give you an example implementation? Sometimes they give you an example implementation. There's a whole load of stuff that goes on inside it. But like that kind of assumes you know what an R value reference is and when you would use it and what an X value is and why you would want to convert a L value, GR value to an X value and all that kind of gubbins. So GL value, sorry. We can go through stuff like that. We will have to use our value references to implement unique pointer. If anyone has done this before, then do keep an eye on what I'm doing and make sure I'm not making any mistakes. But yeah, we'll get onto it. Yes, apparently. Apparently yes, you can create an account on there. I assume it's like a wiki. Maybe you can update it. Although I thought it might have been auto-generated from the standard. I don't know. Do I recommend Learn CPP or something else to go from beginner to intermediate? To go from beginner to intermediate, you just need to write a lot of C++ and just from any particular and like draw upon loads of different resources. CPP-ref, ChatGPT to a certain extent, Stack Overflow. I think you just got to pick a project and just start writing code. And what I always say is, and we will get to the coding part in a second, but this question comes up a lot. Pick a project, doesn't really matter what it is, something that you're going to find fun, and just bash it out. Just write low code, and then the key kind of learning point is, because unlike you can be able to find someone to review it and give you like specific advice, it's kind of you to reflect on it at the end. Take a step back and go like, what did I like? What didn't I like? What worked? What didn't work? What did I find difficult? What did I copy and paste that I didn't understand? And then throw it away and write it again from all the experience that you've gained from just going through the motions of writing it. And then keep going to that to get bored and then do it with another project. And I just think through that, you're like this doesn't feel right. This is difficult. Google it, ask the Oracle, and then find out better ways of doing it. So I've set up a basic little C++ CMake project. I will put all this on GitHub at some point just because I think it's useful. And if you've ever looked at the actual standard implementations, they tend to be quite hard to read, I find, like not by design, but they are battle-tested, bulletproof bits of code, and there's a lot that goes into actually making sure you kind of fully implement the standard. So this will be not 100% standard compliance. I imagine there will be some bits and pieces that we either skip over or just simplify, but we'll do our best to make it as close as possible. There's a delay between video and audio. I apologize. There's probably almost nothing I can do about that, except for, I don't know, I was going to say speak faster, but that probably won't help. Apologies if anyone else is having that. Okay, right, so what have we got? I've got a file, it's pretty good. And then I've got some tests, which is pretty good. Let me know if the font size isn't big enough. So I'm going to stick those all in like my std namespace, because it is undefined behavior to add stuff to the std namespace, and as I'm not committing to writing a full library implementation, it's probably easy just to keep them separate. So I guess, what is a unique pointer for anyone who's unaware? I've just been prattling on about, we're going to make this thing. A unique pointer is no, nice try. A unique, I'll get there in a minute. It really wants to bring in the memory. Right, okay. So a unique pointer just is a smart pointer that models unique ownership. So the idea is that you give it a raw pointer, something that you probably called new on, or, well, dynamically allocated, and you give it to a unique pointer, and it will ensure that it cannot be copied, so that your particular instantiation of that unique pointer is the only owner of that raw pointer. And then but more importantly, when that unique pointer goes out of scope, it will delete or clean up that raw pointer for you. So it's an RAI, what they call RAI. It's a It's a primitive that prevents you from leaking resources and prevents you from accidentally duplicating them. So it's pretty important. I would say unique pointer is probably, you should be using unique pointer pretty much everywhere in terms of when you need to model ownership. So I know that in the standard they like to have a bunch of member types, which is fine because it just provides like a standardized way of the rest of the standard library for accessing certain bits of information about those classes. So using pointer equals t star, and then using element type equals t. So it's kind of a little bit of boilerplate, but what that allows you to do is my std unique pointer int up, and then that can lets you do up pointer, for instance, and access like as a type, and allows you to access the pointer type. So it just means that if you're using this in other parts of the standard library which require knowledge and access to the internal pointer type, it can just use this member type. Right, so if it's going to store pointer type, if it's going to store a pointer, then it needs to store a pointer. So we just right, done. Right, we can ship it. You know, we can stick a pointer in this. We're kind of good to go. Almost. So you can have so you can have an empty null pointer. So you can have an empty unique pointer, which makes sense because you can have an empty or null regular pointer. So if you just construct it like I have here, then this will represent no object. And then you can then have a, what's the exact signature for it? Pointer p. So you can then have a pointer p. I might actually call this. No, nope, change my mind. Obj. P. So, in theory, now I can put in this pointer, and when I construct it with a pointer to an object, then this will store it. Obviously, we can't get it out. We can't free it. We can't delete it. We can copy it. So we're not really meeting any of the requirements at the moment. All we've really done is wrapped a raw pointer in a class. So it's not quite what we're going for, but we're definitely getting there. So what's going to be the next thing? So I guess let's start constraining this, because we actually before we get to the structure, there's a few other bits and pieces we need to go through. So let's do const expr unique pointer const unique pointer equals delete, and then const expr unique pointer operator equals const unique pointer. So what this does is this prevents the copying. So now if I construct a unique pointer, I cannot do auto up2 equals up. It says call to deleted constructor there. This prevents me from copying it. So now I cannot have, once I've shoved the pointer in here, I cannot create another copy of this which also references that pointer. So that's part of the big semantic use, I guess, of this class. Is it is non-copyable, and you can prevent it from being copied by taking the two operators that would facilitate copying and just telling the compiler to, well, don't delete them. Just say don't emit one. Do not create an implicit one for me. I'm not providing one. And then if you use equals delete, then you tend to get a slightly nicer error message, and we always want slightly nicer error messages in C++. And then really, the big one is So the idea now is that when it goes out of scope, so when the object is destroyed, it needs to delete the object. So, I mean, obviously, oh, hang on. Obviously, because you have to remember, we've got to be careful because there is the potential that we don't store an object. So if we have stored an object, then you could be like, oh, just delete it, right? And that'll work. Well, let's test this. Struct foo. Oh, come on, come off it. Overzealous. Oh my goodness, really overzealous autocomplete on this. Either that or I just don't really know how to type. So what I'm going to do is create a object which just has some side effect in the destructor so that we can check that it was indeed deleted. So hopefully this kind of makes sense. Because we need to ascertain that the destructor was indeed called. So what I'll do is have my stirred unique pointer on a foo. Bool is so bool auto deleted equals false. That's a bug there. Just change that, and then new foo deleted, and then we'll just scope this, and then we can do assert false. No, assert true deleted. Right. So what this will do is construct one of our new object with this foo object, and it will automatically it will create a pointer for us. It will dynamically allocate the foo object, so that will go into here, and then when this goes out of scope, which is on line 26 here, it will call the constructor, and then if everything goes right, it will call delete, which will then call the destructor of our test object, which will then have a side effect. So in theory, when at the end of this line, this should become true. Hopefully that makes sense. It's a little bit convoluted, but we'll use stuff like that to test it as we go along. I'm not going to write like a full suite of tests. I can't imagine everyone has decided to kindly spend their Sunday with me just to watch me write tests, but we'll write a few as we go along. Boom, nailed it. Yes, you're right. Calling delete on a null pointer is not an error, but do I need to check this for the next step? Maybe not. Maybe it's just habit. But yes, you are correct. We maybe could have just elided that. Oh, there is no difference between bool deleted and auto deleted. I was going to say it's less typing, but it's the exact same number of characters. I just personally, I subscribe to the AAA, is it the almost auto everywhere theory of writing C++ code, and I just prefer to write auto everywhere. So what you kind of saw was my just own personal preference kicking in when I realised I hadn't done it. It largely doesn't make any difference. Okay, so this is great, but what if we don't want to use delete? So here's where it gets interesting, and I think this is one of the first interesting parts of the class, and we're probably going to go a little bit deep into this. The actual standard lets you supply as part of the template, as a template parameter, so part of the type is a deleter. So we will do that. So we'll say, hey, class, I think let's call it D, and then we will, because we're kind of doing a lot of this from scratch, we'll do our own one. template class T struct default delete. Oh, I need to fix this. Right, okay, so default delete, and then this will have a void or operator t star const, which basically is a function call operator. So I can, if I have an instantiation of this class, I call parens on it as if it were a function, and then it will invoke this. And this will just delete p. I think there might be some member type defs we need to put in here. I'll kind of look at that in a minute. But essentially, this should, if we default this to default delete t, all things being equal, our code should still compile because it's now defaulted template parameter, and it should still work. Okay, so all we've really done there is, oh, hang on. Helps if I actually create it. So nope, delete. Actually, I think that's a member type def, isn't it? Deletes type, yeah, right. Using deleter type equals d, and then we have deleter type deleter. This will deleter, and this will default construct both of them. So, in fact, actually, there's an easy way of doing this. Let's reuse the code. So this now just calls this with a null pointer. So it just means I only have to write the constructor once, and then I can effectively, all the other ones, or in this case, the other one, I can just redefine in terms of the one I've made. So it's just less typing. Yes, this should probably be const extra 2. Good shout. Okay, so now what I do is deleter obj. I think, if I remember correctly, I think most implementations, because I have looked at implementations of this before, not for this, but before, and I'm sure a lot of them check this because there was a time when I was abusing unique pointer to store an integer handle rather than a pointer, which you can do. And then I used the custom deleter to be like a close function, so I was basically passing in, it was like a socket, it was some sort of integer-based handle to some operating system primitive, and then I used the deleter to clean that up at the end. So, you know, kind of getting the advantage of unique pointer, sort of relying on the implementation of unique pointer to do specifically that that cleanup. And it worked like 99% of the time, but if the integer handle I passed in was 0, which for whatever, I can't remember exactly what it was, but for whatever specific primitive that was, 0 was a valid handle, it wasn't calling the deleter. And then once I stepped through it with the debugger, I ended up at the constructor for unique pointer, the destructor for unique pointer, and it had something like this in here, and then 0 was being implicitly converted to null pointer. And yeah, it was then skipping it out, so I was then leaking that resource. So yeah, that's why I think, whilst you might not technically need it, I think a lot of implementations still do it. I just saw a little graphic pop up, which is not the same theme as the other, so that must be from Twitch, and I've clearly not set up Twitch to use the same set of graphics as YouTube, so stream overlays. So that's that's annoying. So thank you for whoever interacted. I will try and fix that for next time. Okay, anyway, I'm kind of rambling a bit about past war stories. Okay, that still works. So what we've kind of done is you can think of this as like abstraction. We've removed the coupling of us to the delete operator and now done it via a default delete. So Twitch raid, I think I know what that is. That's cool. Thank you very much if you've come along. Oh yes, 13 people came along. That's exciting. Welcome. We are implementing some low-level C++ library stuff from scratch just to kind of learn how it works. And you've joined us at an interesting juncture because we're doing custom deletes. So before everyone clicks off because that sounds horrifically boring, there's now a really interesting part of this that I want to go through. The standard says you have to store the delete object. So, because what you could do is you could just create a D here, right? And then do something like that, right? Just create it in line. And I must admit, when I first looked at, when I first kind of thought about the implementation of unique pointer, like many years ago, I assumed this was how it did it, because the point of unique pointer is it's supposed to be a very, very thin wrapper around a raw pointer. So I was like, so if you're thinking like, well, no one spotted my typo, upsetting. So if you think about it, if it's now storing two things, that's not a direct it's not very comparable to a raw pointer, because a raw pointer will be on a 64-bit system 8 bytes. So this will be 8 bytes plus the size of this, which seems strange. But let's have a look at something. Let's do something fun. Let's static assert that the size of stood unique pointer of an int, doesn't matter what the type is, all pointers are the same size for your particular platform. Okay. I'm hoping this will not give me an angry red line. No, and just to convince ourselves it still builds. So, question for you. How can unique pointer store two objects, yet still only have the size of one? Now, you might think, the compiler, it's part of the standard library, they have the compiler has, oh, is my face in the way? Apologies. I'll temporarily move myself. You might think, someone said it, like, oh, it's compiler magic. Like, the compiler has, like, guilty knowledge of the standard library. Like, there's something special about default delete that it knows about. But that's not true, because if we put in my stood default delete int, it's still the same size. So there's nothing particularly magic about it. There's a trick, but it's not like guilty. It's not like the compiler has guilty knowledge of unique pointer and is optimizing specifically for that. It's using a different optimization rule. And what you can kind of see here is if I actually, and it only works because this class is stateless. It doesn't define any members. As soon as I actually put in some data into here, so say I have a member int x, excuse me. Oh, and I save the file. That is key. It now doesn't work. So it's not magic. It has no guilty knowledge, but there is a trick going on, and what we're going to do is we're now going to implement that trick. So that's fun. So hopefully I kind of convinced you there's something interesting going on here. So how big is this class? How many bytes does this take up? That's a kind of question for everyone. I've got one. Yes, so yes, the size of default delete int will also return 1, and I'll explain why. So the size of, you cannot have a 0-byte object in C++. The language defines that everything must have a size, and it has to be at least 1 byte, because if you have an array of them, for example, you have the address of the first one, you have to have some number of bytes between consecutive elements. A 0-byte object doesn't exist. You can have an empty struct. I've got a strange feeling you can't have an empty struct in C, but like I can't remember that. So the size of it. So this will almost certainly be 1. I can't remember the specific if the standard defines the size of empty class, but it has to be at least 1. There is something called the empty base optimization. Let me just check if I'm saying that right. Empty base optimization, which basically says if you inherit from a base class that has no members, the compiler is allowed to remove that 1-byte storage space, because in the derived class that will have an inherent size. So basically, class struct base, struct derived base. If you do size of this, it'll be 1. If you do size of this, it will also be 1. It won't be 1 plus 1. The compiler is allowed to optimize out the size requirements of this because it knows it doesn't store anything. The empty base optimizations. Hopefully that makes sense. Again, I say 1, whatever the standard is, but the compiler is allowed to basically not apply the additional bytes that's required for this on top of that, because this class will still have a size. And again, only if you put in something like that will then this have to make sure that there's enough space for this object. So I think in Boost they call it a compressed pointer. Oh, sorry, a compressed pair. But what you can basically do is if you inherit from the deleter type, and then you store your object in here, right? And then you just create your compressed pair. I can't remember the exact. So we're not actually going to do it this way because I can't, because there's actually a better, more modern way. But this is kind of the gist of it. Is if you inherit from your base type, then the storage requirements for it are can be optimized away. And then what you can still do is you're still effectively storing your deleter, but through inheritance. So then you do, so then that becomes CPP, nice. And then if CP dot p dot obj it's not old pointer, and then you can because you've inherited from it, you also inherit the deleter, you also inherit this function, so you can then just pass that into that. So again, you're still storing both objects, but you are using this optimization to be able to say, oh, I don't want this. And again, it does something like that under the hood. I suspect most implementations do this because I think you need to be able to get a reference to the deleter out, but if you don't want to do that, in C++20, you can do no unique address. And what this does is it tells the compiler, I do not require a unique address for this object. So you are free to optimize things based on that information. And if it knows that this is a 0-byte object and that you don't require to get to a unique address for it, it will optimize the allocation out for it, or the storage requirement for it. So that's kind of, it's a bit of a deep dive sort of into the mechanics of that. But so in theory now, I should be able to do this. Yeah, okay, so now my class also behaves the same as the standard unique pointer. I store this object, but I don't require any space for it. And if I remove that, then I now get the static assert because it's now allocating space for it. So this came in C++20. It's pretty good. It's useful for stuff like this. I'm going to keep this in for the moment. We might have to go back to the old school way of doing it because I think part of the interface is that you can get a reference to the deleter out, which, again, if you've said there's no unique address for it, then the compiler, if you get the address of this object, you can get like anything within the object. So we'll see. But I quite like this in terms of like flexibility and ease of reading. I guess I think this is better, but a bit of a dive into the internals of it all. Right. I will get on to move semantics in a minute, but let's how do we actually get something out of our class? So yeah, so unique, yeah, so no worries. Like, no unique address came in C++20, so it's reasonably new, so it's not something people might have a huge... And it's one of those things that C++20 was quite a big change in the language. You know, we got ranges, we got concepts, we got coroutines, we got... well, I say we got modules, like, they sure put modules into the standard. So stuff like that kind of slides under the radar a little bit, but it's useful to know. So then we've got... element type operator star const no except, I think, looking at the thing, and then pointer operator const no except. Why no Rust? Well, it's kind of hard to write a C++ standard library in Rust. I'm sure it's possible, but I think it's easier to do that in C++, personally. It's gonna move myself back up. Okay. Languages are tools. Like, I get quite a lot of mileage out of C++. So a lot of people solve a lot of problems in C++. Don't really have much more to say than that. Yes, in Twitch, someone's raised a very valid point. No unique address doesn't work in MSVC. You have to do MSVC : no unique address. I don't know why. I'm sure there's a reason. If I ever bump into STL, I'll ask him. Although I guess it's more of a compiler feature than a library feature, a language feature than a library feature. But yeah, you probably need to type def that out or figure that out. But the joys of writing cross-platform code. Let's do value access. So get rid of all this chuff. Don't care about this. My std unique pointer int. I might try and do the make unique if we have time. The factory method as well. New int 42. And then assert equals helps if I give it a name. Beep star p 42. So this is just checking that I can actually get the value out of the pointer, because it's all very well good wrapping it and doing fancy things with empty base optimizations and disabling copying, but if you can't actually get the value out, it's not really a lot of use to anyone. What have I done wrong? Undefined reference. Wait. Oh. Helps if I implement it. So this needs to return star obj, and this needs to return obj. See if that blends. It does. Perfect. Nailed it. Okay, so this is just standard getters, right? So you can treat unique pointer like a pointer. It uses these operator overloads to make sure that the dereference operator and the arrow operator are available. I guess we could. Just satisfy ourselves that this is working. So stick a bar in here, make this a new bar, don't zero initialize it, and then do p dot x equals 42, and then check that p dot x is indeed equals 42. Or I'm wrong. P dot x. No, the circle, the color circle on the overlay for my face does not change with my mood, but my mood would. But that would be interesting. Maybe I'll hook it up to a heart rate monitor, and the more stressed I get, C++, like the angrier it gets. Okay, right. So I think we're probably at the point now where we need to start thinking about transfer of ownership. So the whole point of unique pointer is that it is uncopyable, non-copyable, whichever way you fancy saying it. But we still need the ability to like transfer ownership. So just because like we are the unique, I am the sole owner of this allocated integer, but it might be as part of the interface or part of whatever. I need to hand it off to someone else. I might need to stick it in a vector. You know, I might be done with it and need to hand it over to a different part of the system. And if you can't copy it, then the only way you can do that is by effectively moving it or transferring ownership. Move is kind of a weird term in C++, but C++ being C++, it definitely allows you to do that, and that is with the move operators. But before we get to that, I'm going to implement one more method that I think is useful, and that is void swap unique pointer other no except. And then I will go back and I will spell unique correctly. So swap does kind of what it says on the tin. You give it another unique pointer, and then it swaps them. So again, you're still maintaining the single ownership responsibility of 2 pointers. It's just that now 2 of them, like one now owns another one. Am I teaching a class or making a video? I don't. Neither. I'm just writing some C++ for people to come along and enjoy. I will pack these. All do end up on my YouTube channel as just past live streams for people who are interested, and I might go back and repackage it specifically as like just like the technical content at some point. But for the moment, just spending Sunday evening writing some code with some people. So you say const expr operator overloads, but I don't think these are they const expr? Ah, interesting. They are, but they are not in. That's really interesting. In CPURF, they are not const expr, but in the standard, they are. That is exciting. Maybe you can create an account and log in and make the change. I think that's easy enough to fix. And that means also swap is const expr. I think modern C++ now you just put const expr on everything and hope for the best. But that's a good spot. I mean, teaching passively, yeah. I mean, I'm implementing something from scratch and hoping people find use out of it. Okay, so swap kind of does what it says on the tin. Again, you give another one and give 2 objects, and give another object and you swap the internals of it. There's kind of a couple of ways of doing, because it's C++, there's a couple of ways of doing everything. You could manually do it. So I don't know, auto temp equals obj equals other dot obj other dot even I'm bored of writing this, and it's only 3 lines, and it's also error prone. You could just do std swap other, nope, obj other dot obj, and then you could do swap deleter type, sorry, deleter other dot deleter, which I think will work even with the no unique address. I think it'll work. I'll have to try it out. Anyway, so this is just using the standard swap function, which is fine. The issue is, and it's absolutely fine for pointers. There is swapping a pointer is swapping a pointer. It's going to be about as optimal as you can get. The interesting thing is like swapping a custom object. Deleter itself might have a more optimal swap that it itself defines. It doesn't have to. It could be any function. It could be any class or structure that you want to write. It doesn't have to be this. So by doing this, you're basically just saying to the compiler, use the standard swap, which will probably just do what I did, which is create a temporary, copy one to the other. Unless of course it's move only, in which case I think if it's move only no except, it will create a temporary and move from one to the other. But anyway, you are potentially leaving optimization on the table. If swap is in your hot path, I probably got bigger issues, maybe potentially, or swapping unique pointers. But anyway, we're trying to do things the idiomatic way, and this is not the idiomatic way of swapping. The idiomatic way of swapping is this, which I find quite egregious. Someone's already mentioned it on Twitch. Yeah. So I find this quite egregious. But what this basically does is this now sets up the compiler to have the maximum chance of finding the right swap function. It will look to see if there's a free function defined for your type, and it will call that. It will then use something called ADL, or argument dependent lookup, and it will then look into the various like namespaces and definitions of the type of this object and see, have you defined like a friend swap function, and then it will call that. And then failing that, it will fall back down to the stud one. And by doing this, you kind of maximize your chances of finding the right swap function. I find this incredibly egregious. It's just one of those weird idioms you have to learn. However, if we're writing modern code, which I suggest we do, this will do what you expect it to do. It'll do all that stuff I said before with the correct lookup and everything. It uses ranges nibloids, the customization points. I must admit I can't remember the specific details of the specific mechanics of why it works, but this, as far as I'm aware, is equivalent of using std swap object. Yeah, it's something to do with the nibloids. I've looked it up once and I was like, that's cool, and then I immediately forgot it. I'd have to go back through and remind myself how it works. It basically kind of removes the need for ADL. So anyway, that's a swap. We should swap like that. No, not written shared pointer. This is the first of this kind of series. We'll definitely do shared pointer because there's some interesting things in shared pointer, especially around make shared. You should just keep coming back for more. Okay. So, yeah, I think shared pointer is, I think, mechanically more interesting, although arguably less useful in real world code. I think more often than not, you don't need a shared pointer, you need a unique pointer, but we'll definitely go through and implement it. What if the deleters have different sizes? Bear in mind, the deleter, they can't because they are templated on this type. The deleter type is part of the type of unique pointer, so this will not allow you to swap. This uses, I'm going to say CTAD, but this uses type deduction. It's basically the same as doing this, right? So you cannot pass, it will not accept a unique pointer with a different deleter. If you wanted to do that, which is not part of the standard, and effectively have a polymorphic deleter, then you would have to define a templated swap, which allows you to take an arbitrary deleter and then swap them over. Hope that makes sense. So just, you never understood operator that. It just basically, it is the equivalent of doing doing this, right? It's just a function. This just defines, all this does is define a function that the compiler should call when it sees this on your custom object. I think a lot of coding skills are transferable. You know, an if statement is an if statement is an if statement, right? I think what does differ between languages is the idioms and the best practices. Like what is best practice in Python, for example, which is, you know, throw exceptions for control flow, and, you know, it's better to ask for forgiveness than it is for permission, and, you know, everything should kind of be open. You know, that allows people to write Python code that in theory is largely the same, because everyone has a common set of, like, you know, common understanding of what good Python code is. Those are not necessarily transferable to other languages, because you wouldn't do that in C++. I mean, you can. I mean, you can do it whatever you want in C++. It's got everything. But the idea is to try and build up like a common set of understood rules and idioms and stuff. Then that's the bit that's not necessarily transferable. But I think once you've been writing enough in any language, you can kind of pick up any language you want. I don't know. So yeah, I think someone on Twitch saying that for their implementation they had templated allocator rather than deleter, which again is not part of the standard, because unique pointer itself, as in the standardized one, is not responsible for allocation. You give it a pointer, but it's not, you write whatever code you want that works for you. Yes, implementing unique pointer. I think there was this it's like. In C++, in C, it's really easy to shoot yourself in the foot. In C++, it's much harder, but if you do manage to do it, you will blow your entire leg off, which I always find quite an apt and amusing phrase. Anyway, I hope that kind of explains this. All this is, whenever you do operator overloading, you're basically telling the compiler what function to call when it sees a particular operator, be it a plus, divide, comma, don't overload comma, or for instance the arrow operator. So, right, let's talk about transferring ownership. This will be called with an R-value reference, which basically is the compiler's way of saying this is it's either PR value or an X value. It's the value that I kind of don't care about after the fact. I'm transferring it in. Like, no one should be using whatever object is passed into here. I shouldn't be caring about afterwards, which means we can steal its resources, we can hollow it out, or do whatever we need to, as long as the object is left in a valid but unknown state, I believe is the wording in the standard, or at least for a lot of things, as in you can destruct it and you can assign over it if needed, if it's copyable, but you can at least destroy it without it crashing, or at least it's well defined, then that's fine. So what we can do here is, because this is just a constructor, we can... Sorry. The first thing we can do is we can say, right, this is a constructor. We're being constructed with an R-value reference to another unique pointer. We'll just call this, which we'll just call this. So we'll start off with an empty object, and then we can just swap with R. So what this will do is swap this object with our empty one and put it in ours. So at the end of this construction, the thing that was passed into us is now empty, which is fine because it can get out of scope. It's not going to, it's not going to double delete or anything. And then we maintain ownership of that object. So maybe it's easier if I demonstrate that with a test. Move CTOR. Let's have a look. What's the best way of doing this? Nice. Int, new int, and then std union pointer int p2. So this is where you need the std move. So this will std, because if I just call this like this, if I just try and pass it in, it'll try and invoke the copy constructor, which we've removed, we've deleted, you can't do. So by calling std move, remember std move doesn't move, it's a bit confusing. It just unconditionally casts it to an R value reference, which means now that P1 is in R value reference, it can match this. So the compiler will then call this, it will then swap it out and hollow it out. So this will delete, this will cause P1 to be a null pointer at the end. In fact, let's do const explorer. What was my types? Is it pointer get const no accept turn obj. So what we'll do is we'll go const auto save pointer equals p1.get. So we'll just save off the internal pointer, and then after this move we can do assert equal start p1 null pointer assert equal not that, sorry, I'll get there in a minute, get p2.get saved, and I will fix that typo, I've already seen it, save pointer. Nailed it. Right, okay, so this here effectively allows us to transfer ownership over. So what we can now do, for instance, is if we needed to pass it to a function or put it into a vector, we can kind of use std move on the object to effectually invoke the right constructor. The only other remaining one to do is the move assignment operator, which has a slight other interesting complexity to it. Unique pointer other. Hang on, what am I doing? Right. Get there in the end. So this is what happens if you wanted to do if I defined, make a new test. You need pointer move assign. So create P1, create a P2, and then if I did P2 equals P1. Note that this is different to this, which is also technically the same as So this assign, this equals something, and this equals something are different. What the compiler is allowed to do when it sees an equal sign is it's allowed to call a constructor with one argument. This is effectively called an implicit cast. It's allowed to implicitly try and convert this object to this object. So what the compiler is going to do is it's going to see, oh, you're creating an object with an equal sign and one object. I'm going to go through all your constructors that take one object, a pointer, and a unique pointer, our value ref, and if any of those match, I'll call the constructor instead. So this doesn't. It's different to this where your P2 already owns an object and you're trying to assign something over the top of it. It's just a useful distinction to make because it does have some implications. It does. Well, we'll see what those implications are now. So here, remember, this isn't a constructor. We're not creating in a default state or anything. The this in this case could potentially already own an object. So what we have to do is, because you might be tempted to just be like, oh, I'll just swap other, right? Job's a good one, right? The problem here is that if I already own an object, I will leak that. Well, I'll just I could potentially leak that, or at least I'll stick it in this other object, which is not really what you're potentially expecting. So what you can do is you can go. I have to check. I have to check I get this right at the end. Right. So what this does is it transfers ownership of this into this new object. This will call this. So now we know that other is in a valid but unknown state. It's got a null pointer. Yeah, that's the implementation detail for us, but we know it has that. And now on the stack here, we have the other here, and then we swap with the other object, which now means when we get to here, via this jump, we contain this object, but our stack allocated one contains this original one. So when we leave the scope, this will get destroyed. It will invoke its destructor. It will clean up the resource. So this guarantees that we kind of get this deterministic resource management, because I've transferred ownership of a new object into me, and anything I was holding is immediately, well, at the end of the function call, destroyed. Hopefully that kind of makes sense. Have I got a typo somewhere? If I put P1 equals to move P1 somewhere. And again, this won't work because it's going to try and reach for the copy assignment operator. So we'll do std move this. This will invoke this, and then we're kind of off to the races. Good night. I'm not going to pronounce your name, but you say good night, and I'll say good night to you. Hope you enjoyed it. I imagine we'll probably only go in for. I don't know. Go for it. We'll go for a little bit longer. I want to wrap this up, but then I will make sure that the stream is available for everyone on the channel afterwards. That kind of makes sense. Like I said, there's not a huge amount to unique pointer, but the devil, as always, the devil is in the details. But yeah, this is sometimes called the copy and swap idiom. So you copy in and then you swap it out. It kind of handles a lot of the edge cases and stuff for you. It keeps your code super lean and easy to understand. And again, it guaranteed, because you could just swap out to the other object, and then whenever the object you've moved into goes out of scope, it would delete it. But see, the whole point of unique pointer is it's kind of deterministic resource management. I expect the object that I'm holding here, I expect to be destroyed when I transfer ownership of another object in. I don't expect it to be destroyed when this object goes out of scope. So yeah. So yes, I'm using G-Test. Google Test is my preferred testing framework. They're all the same. Like, they've all got their pros and cons, which means they're all terrible in their own unique ways. It's just what I've used the most. I've used Boost, I've used Catch 2. I like Gtest because it comes with Gmock, and I'm not really familiar with any other alternatives to Gmock, especially given like the amount that Gmock does. So it kind of feels right to me to kind of use that pairing. Can you use 0 as null? So that's inherited from C, is null, is this idea that 0 is like the invalid memory address, whereas null pointer, the keyword, is the instantiation of a null pointer T type, which is a special type the compiler understands and kind of makes it so that you can use it wherever you would expect a null pointer without having to use null, which is normally just hash define 0. So it kind of makes it a bit more explicit in a lot of places. I'm sure that's kind of a high level overview. As with all these things in C++, there's a million nuances. If you are, I don't know if I encourage it, but if you're interested, open the 2,000 page spec and find the specific bit that you're interested in, because I have absolutely not memorized all 2,000 pages, and I definitely make mistakes and can't keep it all in my head at once. Right, let's have a look where we're at. Is there anything else that's worth doing as part of this? You probably want equality. Const unique pointer other const equals default. So the spaceship operator, or the three-way comparison operator, I believe if you have a defaulted one, this will also give you the equality operator, although it's not guaranteed to be the most optimal. For that you could, if you wanted to, but it will be optimal for this. Let me name that. And as a C++, I want to say 20, but it might be 17. If you define the equality operator, you will automatically get the inequality operator for you in terms of the negative one. So you don't have to do that. Yes, well done. Well done indeed. Thank you. So again, like that gives you like the less than operator, the greater than operator, which you might want for pointers if you are potentially wanting to, if you care about like the relative addresses, like where the relative addresses of them, or at least the addresses of various pointers in relation to each other. That might be useful. So that kind of gives you that for free. I don't think there's anything else like too like fancy in this. I think everything else is kind of par for the course. You could have const expra explicit operator bool, just all the keywords, like every single keyword you could possibly imagine. Return just get, no, well, whatever, just obj doesn't equal null pointer. Let's use one. So this allows, by making this operator, this allows you to use the object in like if statements and stuff like that. So you could do if p like that. The reason it's explicit is because it means it allows you to only use it in places where it is contextually convertible to bool, not like value based of convertible to bool. And what by that means, you can use it in if statements and for loops and while loops and stuff like that, but you can't actually accidentally create a bool object from it and, I don't know, try and set it to false or apply like a bit operator to it. Before explicit operator bool came in, and I want to say C++ 11, but I could be wrong, there were some absolute heroics you had to do to kind of emulate this. So that's kind of one of those things where an additional keyword made life a lot easier. What exactly does the default do? I assume. Do you mean for this? That is an interesting point because you've got the deleter. I assume it's going to try and, well, operator equals by default will just operate. It will just call the equality operator on all your sub objects. So I think with the spaceship operator, it does the same as what the equality operator does, and it will call this operator on all of the objects and kind of aggregate the results. I think so. It's basically the equivalent, probably the way that you would probably write it yourself, but the compiler's going to lay it out for you. I very rarely use the spaceship operator. I just wanted to put it in because I think it's fun to say and it's fun to write, because it's got the whole like weak ordering, strong ordering nonsense in it. I suspect for a class like this, it probably does what you expect it to do. And I think it's defined. Yeah, it is part of the standard. Although they seem to say that they would define them all separately, and then that, which seems like a bit of a waste of time because the whole point of this. I guess this is since C++ 20, so I guess you get these for free if you implement this in C++ 20. Before that, you have to do the hard. Well, you technically only have to implement one less than, and then if you implement less than and equality, those two, you can implement all the other comparison operators in terms of that. And then I guess the final one really is we'll make unique. So template class t class dot args nope unique pointer t make unique args. I always get this thrown around. I think it's ampersand dot args. I think. And then I don't need that. Right, and then return unique pointer t new t. In fact, actually, I don't need ctad that. New t stood forward args args, then expand the parameter pack. I think that's the right syntax. I find that template parameter pack quickly, varied templates quickly descends into token soup. But I think that's right. We can sure give that a go. What have I changed here? Use undeclared. Oh, where's me? Where did I save pointer go? Oh no, because that was it. I just never got around to implementing it. That's fine. Do that later. Test unique pointer. Make unique. Unique. Thanks for following. Much appreciated. And then I don't know. Auto pointer equals stood make. Nope, not stood. It's my one, isn't it? My stood. My stood. Make unique int. 42. It's not a particularly great example because it's only one template parameter, but that's. I can't remember if this will forward these on to the aggregate initializer for us. There's only one way to find out. Auto p equals my said make unique bar r 1 2 3. Does that blend? Ooh, exciting. Assert equals p. I could do an operator over it. No, getting ahead of ourselves. P dot x1 fx ry rz and then drop alright. Well, it's only builds, so it must work. Nice, nailed it. So yeah, that's make unique is largely just that. It just takes a variable number of arguments and then forwards them on. So the difference between forward and move, Move is an unqualified cast to an R-value reference, whereas forward preserves the initial value category of the input. So this, because it's a templated type with with a double ampersand, that does not mean it's an R-value reference. It's actually a forwarding reference. It will bind to, it'll be an L-value reference if you pass in an L-value, and it'll be an R-value reference if you pass in an R-value, which is confusing. And so what forward does is just know what that is and correctly push them on to the right place. Because C++ is incredibly complex and value categories is very strange. If you're coming from any other language, args is an L-value, even if this is an R-value reference. Well, it's not because it's a template, but... X is an L value category to an R value reference because you can take the address of it. Anyway, that's by the by. So yeah, that's just what forward does. Forward and move are kind of like the two utilities for working with R value references correctly. I say correctly, I get it wrong all the time. I'm trying to think of anything else that's worth doing. I'm not too fussed about make unique for overwrite. It's pretty niche case there. There's release and reset, but again, these are kind of like, I think if you went down and implemented this, you've kind of got enough to get you going. I think this covers the majority of the bear traps that are waiting for you when you do this kind of thing. But I don't know, there's a bit of time left before I was going to stop. I haven't answered if anyone's got any questions around any of this. Otherwise, I can kind of just keep adding little bits as we go along. But if anyone has any questions, I'm happy to go through it. If any of that doesn't make sense, I do feel like we've covered quite a lot of this. Just going to check I haven't missed any questions. You only need equality. Sorry, Spaceship will give you equality if you default it. If you create your own one, it will not also there infer. It will then from that not infer that you need an operator equality sign, because in a lot of cases this will just implement equality potentially in terms of like the less than, the comparison operators, which is not necessarily the most efficient way of doing it. So for default, the language says that's fine. If you're doing something special with it, then it says you're probably going to want to give your own equality operator. Can I test for the equality check? Sure, let's do that. What's that going to look like? Because you can't... Oh, it's pretty... So yeah, okay, fine. Unique pointer P... new int. I mean, all you can really do is actually, I suppose that's normally I would use ec for equality, but you actually want to explicitly see it being called. Deleted. What have I done wrong? Oh, that's swert. Yeah, thank you. That's my favourite type of assert, that. Have I made a mistake here? What have I done wrong? Cannot be compared because operator is implicitly deleted. I don't think it is. Yes, it is. So it is under it. So unique pointer, because it just wraps a pointer, has the same guarantees as a pointer does. So it is undefined behavior to compare pointers that are from different allocated blocks of memory. So effectively different arrays. So whilst you might have done one allocation and another, this one might be in, like if you actually look the addresses. This one might be less than the other one, but that is undefined behavior. They have to come from the same allocation, and unique pointer follows the same rules. As far as I'm aware, I don't think unique pointer in any way legitimizes you doing anything with a pointer that was. I don't think it defines anything that is inherently undefined with a pointer. I don't know. What have I done wrong? It might just be something to do with the implicit casting. Let's just... Yeah, it should implicitly create a unique pointer from the null pointer, right? I think that's how it works, right? It's how it works with most operator overloading. The compiler is allowed effectively one go at doing an implicit conversion, one implicit conversion to make those types work. It doesn't compare the underlying object. Let me just get docs up. It's probably easier to go through it. There you go. So operator equals blah blah blah. It compares .get. It doesn't compare the values. It just compares the pointers. Again, unique pointer is just a thin wrapper around a raw pointer. It provides like no contextual additional informational semantics over a pointer. You can just, in your mind, you should be able to see it as a pointer. Because its operator is implicitly deleted. Why was that? But it's not implicitly deleted. I've declared it. It even says default. Is it the const expr? What is... Am I going mad? Like... is it? You might be right. No, this won't be. This will have a default destructor because rule of zero, right? I've not declared any of them, so therefore the compiler will create all of them. But it will. I bet it's. Yeah. I bet you're right. I bet it's. I bet you're right. Oh, sorry, I thought you were talking about the destructor. Operator. Bool. Operator equals const default delete Center const equals default. I say this a lot on stream when someone points out something. I'm like, I bet you're right. And then sometimes they are, sometimes they're not. And this time you are correct. Thank you. Yes, well done. What I actually probably should do is implement it myself, because according to the standard, it only cares about the pointers, not the deleters, which actually makes sense because because it's constructing a deleter, that will be different every time. So actually, I don't think we can get away with this. I do think we need to do. That's a good point. Get there in a minute. Right, which probably means we then have to do the rest of them. But, well, actually, I think as of C++20, I think just defining the equality operator gives you the inequality operator. Is a unique pointer, shouldn't a unique pointer always have a unique pointer? So when can equality ever be true? If it isn't, I think you're right. I think this is only useful for checking against null pointer, because it doesn't make it as far as I'm aware, it breaks the contract of unique pointer for two of them to have the same object. I mean, I'm not saying you couldn't do it, because you could effectively provide a no op deleter such that it didn't double delete your object. But I mean, I think you're kind of pushing the boundaries of what I mean. Just because you can doesn't mean you should. Yes, it is probably just there to check against null pointer, and then the comparison operators like less than that are for checking relative the positions of pointers relative to each other from the same allocation or from the same. I can't remember the specific wording in the standard around it, but it's something. I can't remember if it uses the term allocation or if it's just from the same array. It might just be from the same array. So yeah, you could do operator equals null pointer t, but what happens if two unique pointers both contain a null pointer? Those are technically, as far as my implementation of the standard, like these should equate equal. So I still need to be able to compare unique pointer and unique pointer. But yeah, so I think you should be able to do that, right? And that should then, because of the implicit cast, should actually construct another unique pointer, or generate a PR value for it, whatever you want to call it. So yeah, you can take a reference to a unique pointer. Again, I don't know why you ever would. So I guess this is more of a design question, right? So let's just go through some uses of unique pointer. I've typed stud now. I guess I'm committed. The semantics of this function are basically saying I am taking ownership of this pointer. The only way to call this function is to either construct a new one, right, or to stud move in an existing one. Either way, this function here takes ownership of this unique pointer. So what you're basically saying is when you're doing this, right, which is valid, you're saying I want to access this unique pointer object, but I don't want to transfer ownership of it. I want just a reference to it. I mean, constant on constant is kind of the argument is relevant. It's the same for both. This basically means, in my mind, that this function here needs to peek at the internals of pointer. It needs access to that pointer, but it doesn't need to extend the lifetime of it, or at least it shouldn't do. So what I would suggest you do in this case is just pass a raw pointer. I think this is a legitimate use for raw pointers, is if this function just needs to do, I don't know, whatever, prints it, needs to do some computation with it, needs to interact with this object, but not extend or take the lifetime or take ownership of it, I think it's perfectly acceptable just pass raw pointer. And you would do this by this, right? You'd just be like p.get or reference. You know, you could also do a const reference. If you know it's not going to be null, then you could also do that, and then you just pass in start.p. That, in my mind, that's idiomatic use. Unique pointer is for basically modeling the ownership, and wherever that unique pointer lives is where that object lives. But if other code needs to use what is effectively wrapped up in that unique pointer, then you just give it the raw pointer. Like, there's absolutely nothing wrong with that, or a reference to it, as long as. And then in my mind, when I see code written like that, when I see this, assuming no other documentation or pre or post conditions or anything like that, my assumption is that this function does not delete it, does not take ownership of it, does not preserve it longer than it should. And in at least the code I write does. Do you know what I mean? You can't speak for other people. But then in the interface, in my kind of ideal interface, this is just a peek operation. This is just a way of accessing something that is managed by someone else, so I don't have to worry about it. Hopefully that kind of makes sense. I think that's a bit more idiomatic. Maybe that's a bit more interesting than the mechanics of unique pointer. Is what is kind of some ideas around idiomatic usage. Yeah, so this is NeoVim with kickstart, and then my theme, and then, well, not my theme, the theme I use on everything, and then a couple of other plugins and stuff, and Tmux, I guess, most importantly, which is why one of the reasons I switched back to NeoVim from VS Code is because I just really missed, like he says, getting it wrong, really missed. Yeah, to just have multiple panes open. Could a weak map make sense for making a reference to a unique pointer? I don't really understand what you mean by weak map. If you're talking about weak pointer, then that's specific to shared pointer. Like, hey, I need to check if the shared pointer might go out of scope without me maintaining a reference to it, and I need to check it and potentially convert it to a shared pointer and extend the lifetime. I don't know if that's what you mean. Anyway, I think let's think about wrapping up there. But before everyone disappears, for people watching on YouTube, I have memberships that I can gift. I don't have that on Twitch yet. I apologise. But yeah, hope this was fun. I'll try and comment this up and push it up to GitHub. I'll put it on the YouTube when it is up. I'll stick a post on the YouTube community post. So I guess anyone who's watching on Twitch, I have a YouTube channel where I do lots of stuff like this and low-level game reverse engineering. You should come along, check it out. I think I enjoy doing it. And then I try and stream every week and every 8 o'clock UK time, which is currently BST, on Sunday, and we do something fun. We've been building a hacking framework, a hacking toolkit. We've been doing some low-level C++. I've been doing some code reviews, which has been good fun. Could I do a video at Portal? Portal is on my to-do list, which is only ever gets longer and never any shorter, because everyone has such amazing ideas that I think I should definitely do that. So it's on the list. Yes, a year ago I made a video called I Made the Same Game in Assembly C and C++. It is my most popular video and is not the kind of style of videos I make now. People are very opinionated on it, which is hilarious. It's very short, it's only like 4 minutes. I apparently committed the absolute heinous act of doing a dynamic memory allocation in assembly, which really not everyone agreed with, so that's fine. But I'm yet to recreate the absolute massive success because I think it's at 700,000 views, which is absurd. But yes, that was the video I did a year ago. Still trying to... I think the content I've kind of figured out for myself now is... I think like low-level games, kind of like hacking and reverse engineering seems to be... like I find it enjoyable, I find it challenging, and it seems to resonate with a lot of people. Gets good views, gets good engagement. I think that's kind of what I'm looking at doing now. And then the live streams are for more of the software engineering, so the forward engineering rather than the reverse engineering side. At the moment, I'll still throw out a few videos on C++ and stuff, but yeah. But that's a good point. I am editing the next video at the moment, which is exciting because it's been a little bit delayed because one, it was way more complicated than I thought it was going to be. Like really complex. Two, I've just had other stuff going on, so I've not been able to dedicate as much time to it, but I'm editing it now. My aim is to get that out next week. Quick plug, members of the channel do get early access to it. Just going to say. What I want to do is for the next stream. So next weekend I cannot stream, unfortunately. I have other commitments, but that's fine. But the next stream I want to do, I'll put that on the community post so everyone's aware. What I want to do is do a stream on the video, as in like, let's just go through all the technical content in the video in like a more relaxed kind of like less time sensitive way. I say time sensitive because to make a YouTube video I cut a lot out, try and tell a story, keep a reasonable cadence. There's some stuff that kind of have to not necessarily gloss over, but I don't maybe dive into as deep as stuff as maybe as some people would like. So I think it might be fun just to kind of involves Ghidra. We'll get Ghidra open, we'll get a debug open, and people can just ask questions and we can kind of just dig through the project. Hopefully that'll be interesting for some people. I'd quite like to see how much of it I can remember after having filmed and edited it and then forgotten about it for 2 weeks. But yeah, I think that should be good. You should definitely come along. Anyone on Twitch who is new, hello. Anyone who's on YouTube who's new, hello. I hope you enjoyed this. And that's what I've got. I hope everyone enjoys the rest of the weekend, and I'll see you all on the next stream.